All right, so here we go. This will be the last set of videos for this chapter before we have our test. All right. Um, in this section, what we're going to be doing is you can kind of see. I mean, you guys have already looked at the picture there. In the way that we took apart the pulleys, and we had to think about the different things that were happening to a pulley and look at one pulley at a time and see what was going on. We're going to be doing that same process. We're going to be kind of taking things apart, sort of mathematically or, in our imagination, and trying to figure out for each one of those pieces what exactly is going on. Okay. So in some ways, this is kind of like doing trusses. All right. But the method of joints and the method of sections isn't going to work as well for us here because these are not rigid structures. Okay. So if you look at the thing that we've got here, this kind of weird ladder looking thing. All right. If you disconnected A or C, the whole structure of the thing will just come apart. Okay. And so while it was important when we did trusses to try and think, okay, so I got to work out what's going on here at A, I got to work on what's going on at C. That's not going to be helpful here, and in fact, it could lead us astray. Okay, and I'll illustrate that in just a few minutes here. So let me get rid of those guys right here. All right. So what we want to do in these situations is we want to think about each piece. Okay. So I might, for example, have this member right here, BC. Okay. And I want to think about everything that's happening to that piece. All right. So obviously there's this force right here, P. And then we know there's going to be some upward force here. And we could imagine if there wasn't something over here that it would try to pancake. All right. And so we'll call this a CY and we'll call this a CX, just like that. And then we'll come up here on B at the top and we got to figure out what's going on. Well, it makes sense that if we're pushing down on this thing, it's going to try and fall over. And so that means that there's a push on it this way. So we'll call that BX. Okay. Get my X in there. All right. But there could also be something going on here, BY. All right. We don't really know at this point. Okay. Now, if you take any one given component like that, you can see it's going to get pretty messy because I'm going to need to do that with AB. So if I do it all on one diagram, then I'm just going to end up with a mess. And so what works better is to think about it in pieces like this. Okay, so there's my component right here. Okay, and all the forces that we just talked about. We got, whoops. Let me switch my pen there. All right, so we've got a CY, a CX. P is our external force. And then we talked about how it has to be supported here and has to be supported there. Okay, and so we draw that piece all by itself. Okay, now I'm going to go back. And I actually want to get rid of all of these things here because we're going to do the other piece. Okay. Now this other piece is here. Just like this. Okay. And if we think about what are the forces on it. Okay. Again, we'll have something here. We'll call it an AY. And then something here, we'll call it an AX. All right. And then we've got this moment going on right here. So that moment is trying to twist that thing on us. And up there at the top, Okay, you can imagine B is going to try and fall over, so we got to push against it. Okay, and so we would expect this. We'll have a BX there. Whoops. I don't know what I'm doing there. I'm out of control. Let's get that cleared out of there. Okay, there's a BX. Okay, and then, we got to figure out a BY. Okay. So here's where you got to kind of think about things just a little bit, because what we did before is we just went in here and we said, oh, we're just going to have BY like this. Okay. But here's the thing. What one member does to the other does back to the one, but in the opposite direction. That's Newton's third law. So if I push here, okay, these knuckles are pushing against these knuckles, okay? These knuckles experience a force this way. These knuckles experience a force this way. Those are equal and opposite when I'm pressing on each other. So if we go back over here to our individual pictures, you can see what we have to do. Here's my beam. Whoops. Here's my beam. Okay. And there's my A. Oh, I did these all in green on the other one. Here's my AY, my AX. Okay, my BX. Okay, which is the opposite of BX over here. So that's good. And then BY, we're going to have that go down because on this side we made it go up. Okay, we made it go up. Now, at this point, you guys have enough experience when you're doing equilibrium stuff. You know, when you're trying to predict which way a force should go, use your gut. Okay, use your intuition, and then in the end, if you end up getting a negative number, that just means you guessed wrong, and okay, no big deal. It's in compression instead of tension or something like that. It's left instead of right. That same thing still holds true for us as we try to get a handle on these internal forces within the structure. Okay, and so as long as I make my BX's in opposite directions, it's fine. As long as I make my BY's in opposite directions, it's fine. Okay. So we don't really know which way BY goes. Okay. If it's actually down on the left one and up on the right one, or the other way around. We don't know anything about that yet. Okay. But this is what we are going to get a handle on. Okay. Now, once we have exploded our image, our object, and we're looking at the different forces that are acting on it, at that point, then we use all of our regular equilibrium tools. Okay. So on each of these components, then, what I'm going to end up doing, so I'm going to look at Fx, Fy, and I'm going to pick a moment. So let me call that Mx. Okay, I'm going to pick a moment. Oh, let's call it mystery. Mystery. It's a mystery point. But anyway, it's going to be 0 when I put it in there like that. Okay? All right, so there we go. Now, let's look at another one here. Okay, and this example, its only job is to show you that this is a scalable thing. Okay, so we can sort of pick a layer, kind of. Okay, pick a layer. So how much do you want to zoom in on something? Okay, so if we just think about the object as a whole, okay, so I've got this weird thing here. There's a pulley. There's a mount, and a pulley. If I just think about that guy all by itself, all right, then you can see we're going to have these external forces acting on that object. Okay. An external force and some reaction forces there. Okay. However, we could, instead of doing it that way, we could choose to think in terms of what's happening with each pulley. So I believe this pulley goes here. Okay, and I've got this pulley. Let's see if I can move that one over here. Okay, and then we've got the frame itself still here, just like that. Okay, and let me move that over here. Oops, how come I didn't go? There we go. Okay. All right, so let's take a look at what we've got going on here. So let's start with this wheel right in here. Okay, so that guy right there. Make my picture a little bit bigger. And here's the axle. Okay, and the axle is getting pushed up here. And at the same time, the axle is pushing down on the frame component. Okay, so each of them perceives something different. The axle for the pulley thinks that the frame is pushing up on it, but on the other hand, the frame thinks that the pulley axle is pushing down on it. So again, there's that equal and opposite thing. Okay, now we have obviously our external 75 pounds, and so the rope coming over here has to be 75 pounds. Okay, and in order for my pulley to be in equilibrium, if there's 75 pounds pulling then to the right, then that means there's got to be something pushing back on it this way. Okay, and then that means over here we have to have an equal and opposite force right there. Okay, and just by looking at our little pulley, the green one there, you can see BY will have to be 75 and BX will also be 75. Okay. Then let's look at our other pulley. Okay, so I'm going to use another color here. Okay, same sort of thing on it. There's something pushing up on the pulley. Okay, but then the pulley pushes down on that. Okay, there's a tension over here. And so something has to push back, which means there has to be something over here. Okay, this tension down here has to match this tension up here like this. Okay, so everything's going to match in an equal and opposite way. Okay, until finally we get to A down here. So we're going to have our AY and our AX there. Okay, just like that. Zoom back in on that. Okay, so kind of an interesting structure there. Again, it looks like there's no real function for that thing other than being an exercise. Okay, so here's another one. All right, and what you ought to do is pause the video right here and go through each little piece here and see if you can understand what's going on. Okay, and then when you're ready, then go ahead and start the video again. All right, so if we were live in class, for example, that's what I would have you do. I'd say, okay, draw this, find all the pieces on it, and at this point, and usually then what happens is 80% of people go, oh my God, I'm not an artist. How am I going to do this? But just do your best. It doesn't have to be a great drawing. It just has to be practical. Okay, it doesn't have to be beautiful. Okay, did you do it? All right, let's take a look at everything. So this piece here is this guy. Okay, and on that little dude there, we're going to have like a normal force, which is coming up from below over here. dy is here and dx is here, and those are coming off of our figure or our arm there, right there. And of course they sort of interact in the opposite direction than here. Boom, boom. Okay. Now, that long piece right there, let me give it a color. Let's say this long blue piece right here, which is this guy. Okay. Notice it is not a two-force member. Okay. It's not a two-force member. This piece right here, this little short piece, is a two-force member. And as a two-force member, we know that the direction of the force on either end is on that line of action between the two connections. Okay, just like that. But with our blue piece, EBD there, we don't get that luxury because it's not a two-force member. Okay, we've got these other things going on. We've got this piece right here, okay, which comes from this guy, and then we're going to have this piece right here, okay, just like that. And with my littlest piece, that means I'm going to have something like this, okay, on the other end there. Okay. Anyway, you're going to get really good at doing these. Okay. And again, the main thing is just make sure you do the opposites. Okay. And again, if you've got these two pieces and you're not sure which way to put the arrows, it's okay. Remember, it's going to come out in the wash. Okay. Just pick one, put your head down and go with it. Okay. And if it turns out to be negative, well, that's okay. You still figured it out. Okay, so now we're going to put some numbers on one. Okay, so this example says determine the horizontal and vertical components of force which the pin at C exerts on member BC of the frame. Okay, the pin at C. That's what we're interested in. Okay, so let's take a look at this guy. All right, there we go. Okay, now I'm going to show you why in just a little bit, but realize that this is not one solid piece. And I kind of mentioned this once before. If it was one solid piece, what happens at C would actually be different than what we're going to have. Okay? And I'll show you how that works out because it's not intuitively obvious. All right, it's not intuitively obvious, but the reason that it's different is because that hinge pin will not transmit moment. Okay, so let me pull that off of there. All right, so we have to look at our different parts. All right, so we got this top part up here, like so, and your book's got it over here, nice for us. Boom, 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 boom. Okay. All right. Now you're going to want to read through all these examples in your text very carefully. Okay. Just in case there's some details that I didn't get. And then they can sometimes talk about things just slightly different, and hearing two different ways of talking about the same thing can be really helpful a lot of times. All right. So they're guessing that CY is up here. Okay. And now, when I worked this, what I did is I just went ahead and did this. I said this is going to be a BY. Okay, just like that. And that means I'm going to have a BX here. And BX is pushing to the right, so we've got to have something pushing to the left. So that's how we know for sure that CX is pushing that way. And that matches our intuition. I mean, if this thing is like trying to come this way, the wall's going to have to force it back on us, just like this. Okay. All right, so I got to rearrange this a little bit here. All right. There's probably 2 or 3 different ways to do it. I'm just going to show you how I went about it. And what I did right off the bat is I put a pivot right here at B. Okay, and so then I was dealing with my moment at B. Has to be 0. And so I had a negative 2 by 2000 plus 4 CY. And so right away I learned that CY has to be 1,000. Okay. All right. Now, vertically, okay, what we're going to have is CY minus 2,000 plus what I called BY. Okay. And from that, we learn immediately that BY is 1,000. Okay. Just like that. Now, how are we going to get BX and CX? Well, we get BX and CX by realizing that BX and CX are related. Okay. Tangent of theta is BY divided by BX. Okay. Because that's true, because this guy's a 2-force member. So this is it right here. Okay. Since it's a 2-force member, then we know the directions here and here. Piece of cake. So when we get ready to put in, all right, so BX is pushing this way and BY is pushing this way here. Okay. So what we know then is that BY and BX are the vertical and horizontal components of FAB. Okay, and so that's why it's got to go as tangent of theta there. Theta is 60 degrees. Okay, it gives us that geometry. And then we find that we'll be looking at tangent of 60 degrees. It's BY over BX. And then we learn that BX, once we do our math, is 577.4. Okay. All right. So that's pretty good. Let's see how we did here. So we got CY. We got BX. That's there. We got BY. That's there. Oh, CX is going to have to be the same thing as BX. Okay, so we got that too. All right, so we got everything that we would want out of this. Okay, and we were only asked to investigate C, so we got CX and CY right there. Okay, piece of cake. All right. Okay, so here's what I promised I was going to do for you. We found that CY is 1,000, but let's take a look. If this piece over here, if it were just all one piece, okay, make that one piece. And then we've got CY here, and we've got CX here, okay? All right, and then you can see when we go through here to figure out what CY is going to be, like if we were to put our pivot over here, for example, okay, then what we're looking at, yeah, I would have this over here. Yeah, okay. So I didn't work this out ahead of time, and I don't want to risk doing it on video and making a stupid mistake. But if we went through all that, we would get different answers, I think. Okay, on that. Okay, so that's not a good way. It's not a good way to assume that it's going to be as if that they're all glued together. Okay, I hope that's making sense. I got to get to the next one here. Okay. So, let me zoom in on this guy here. So we've got a beam. Find the components of reaction at its supports. Neglect its weight and thickness. Okay. So, over here at A, the beam is actually going to have to be like embedded in the wall or something. Okay. We don't exactly know what's going on. Okay. But we do know C can only be up So there's my C. Okay, just like that. So let's look at our individual pieces. Okay, and here is the blue beam here. Okay, and then I'm gonna call this little guy here green, and this is my green one over here. Okay, just like that. If you have a distributed, we're going to do BC first. If you have a distributed load, like we do here, we know the density there. You're going to have to figure out the magnitude of that thing and its location. Okay, before you can do anything else, you have to do that first. Okay, so you might need to go back and review how that kind of stuff works. All right. But once we do that, then let's come in here. Let's take a look. Okay. So we've already got C. We talked about that. And we talked about BY here, just like this. Okay. And, well, look at this. This is interesting. They've gone ahead and drawn in a BX and put it in here both ways. But look what we learned right away. On our green piece, there's no force back this way. Okay? There's no force back to the right. And so that tells us that BX is going to have to be 0. Okay, so BX is 0 there. Okay, so that's good to know. That's good to know. So all we're going to get out of this guy is CY and BY. Okay, and so if we put a pivot here, okay, move this around just a little bit. Whoops. There we go. Okay, my 8 kilonewton force is out there, a distance of 1. So I've got a -1 onto 8 plus 2 onto CY. And so that tells me that CY is going to be equal to 4. Okay. And if we do the vertical equilibrium, okay, we're going to have BY minus 8 plus CY, and then that's going to tell us that BY has to be 4 also. Okay. Yeah. At this point, you guys, you don't necessarily have to go through that formally, because you can look at it and you can say, well, it's in the middle. Okay. If it's in the middle, then I know that they have to be balanced on both sides. They're going to have to be equal. Okay. But if there's even the tiniest doubt, double check. Okay. Double check yourself. But you at least need to, like on a test or something, if you don't go through that, at least say something like, because of symmetry, we know that BY and CY are going to have to match. Okay. So you have to at least have a reason for why you're doing it. Okay. Don't just, if you just write it down on a test, oh, okay, without a reason, I can't give you credit for that. Okay. All right, but we figured out CY and BY. Let's move to our other piece over here now. Okay, so if BY is up over here, then that means it's down over here. Okay, just like that. So let's go ahead and start with the vertical and horizontal forces. Okay, so here we're going to have AY minus 8 minus BY. Okay, where's that 8 come from? Some of you might be wondering. How did I get this? It comes from this. Okay, it's a 10 kilonewton force, and my vertical component is 4/5 of that, so that gives me the 8. Okay, BY we've already figured out that was equal to 4, and so what we learned then is that AY has to be, we'll move it all over. Okay, AY has to be 12. Okay. All right. So AY is doing a lot. Okay. AY is doing a lot. Now let's get to the horizontal bits. Okay. And now we're going to have AX and minus 6. Okay. Has to be equal to 0. Because BX is already 0, we figured that out. Okay. And so we can see that AX has to be 6. Yeah, okay. And very good there. Okay. And again, hopefully that makes sense. I've got my 3/5 component. That's how I came up with the 6 there. Combined the 3/5 with the 10 to get the 6 there. Okay. Okay, so far so good. Now, some of you probably figured out, now wait a minute. Just looking at this thing here, it doesn't look stable. Okay, your intuition, your gut may be saying, that doesn't seem stable to me. What is actually holding this thing up? Okay, at point B, there actually isn't anything underneath it. Okay, so what's to keep it from folding? What's to keep it from folding? And the only thing that can keep it from folding is if we have a moment this way provided by A. Okay, only if A provides that moment. And that's why I said it's got to be embedded in that structure somehow, or somehow the way it's connected has to be able to provide a moment. And I'm going to call that moment, whatever it's providing there, I'm going to call that MA prime. Okay, that's my notation. I'm going to call it MA prime. I mean, you'll see why here in just a second. Okay, so now let's go back to our analysis of the component AB. Here we are. Okay, so the way I have been doing this for you all semester is I notate it like this to say that we're summing the moment at A. So that's why I wanted to call this MA prime. Okay, now if you want to give yours a different notation, that's fine. You go for it. Okay, this is just the way that I'm doing mine. Okay, so if I look at this, then I'm going to have a positive moment, MA prime. Okay, and then my 10K force is going to produce a negative moment, so it's out there at a distance of 2. The vertical component is 8. And then BY is down. It's at a distance of 4. BY, just like that. Okay. 2 by 8, 16. 4 by 4 is another 16. And so MA prime is actually 32. Okay. It's actually 32. And, you know, if we didn't need a MA prime, then we would have gotten 0 out of that thing. And we would have been like, well, that was a waste. Okay, so let's back up here. This was a kind of a juicy one. And take a look at it. Okay, and so we've got our two pieces here and here. Okay, and we're going to analyze them one at a time over here like that. I chose to do this side first because I recognized the symmetry of my force distribution, and I knew that BX and CX, BY and CY were going to be equal. And so I thought, okay, well, that looks like an easy place to start. I didn't know for sure. I just said, well, it looks like an easy spot. Put my head down and go. Okay. These problems are really at a point now where they're too complicated for you to try and see in your head several steps and know, oh yeah, this is the way I should go or not. You're just not going to be able to do that. So pick away and plow through it. Okay. Pick away and plow through it. See what you get. So I used all the stuff we normally do. So I have moments, forces. That got me everything over there. And then I came over here. We did forces moments. Okay, just like that. So what was a little unusual was having this moment provided by our support over there on that side. So we haven't seen much of that kind of a thing, but we've seen it before. Okay. All right, so I'm going to end this video. It's gotten kind of long, and then the next videos will be more of what I normally do for you, which is the fundamental problems. Okay, I will go just a little bit faster on them. I won't stop so much to explain things. I'll go just a little bit faster. Okay, so I tried to take my time here and make everything as clear as possible. All right. See you in the next one.